Hey everybody, welcome to the first edition of the Lab 207 Earth Science webcast. My name is Mr. Kite and I'll be hanging out with you today. We're just going to have a quick little talk about tectonic plates or plate tectonics, whichever way you want to call it, and why they move. So anytime I do one of these webcasts, I like to start out with the objectives. Here's what you need to know by the end of today's video. Describe the process of convection, relate convection to the movement of tectonic plates, and compare and contrast ridge push and slab pull. I guess those are more do's than no's, so make sure you can do these things by the end of the video. So I want to start out with a quick little review of the three types of plate boundaries. Now, if you'll remember, the surface of our Earth is kind of like a hard-boiled egg that's been cracked. If you were to take that hard-boiled egg and crack it against, a counter or something, the inside of the egg would represent the inside of the Earth. The shell on the outside that is now broken and cracked represents the crust of the Earth. We live on the crust of the Earth, and the crust of our Earth is broken up into a bunch of different pieces, kind of like that egg that you just thwacked against the countertop. So on our Earth, each of those pieces of the crust is called a tectonic plate, and those plates meet up at places called boundaries, and there are three ways that plates interact at boundaries. The first type of boundary or interaction is called a convergent boundary. Now let me call up my little pen here. At a convergent boundary, here's what you got going on. You've got one plate traveling this way, you got one plate traveling that way, and it is just like a car wreck. They run right into each other. One of the plates, the plate that is more dense, gets subducted down into the Earth where it will melt and be recycled. The other plate travels up on top. So for a convergent plate boundary, I just want you to remember that two plates are colliding with one another. The next boundary that I want to remind you of is a divergent plate boundary. Now, in a divergent plate boundary, you've got two tectonic plates that are moving away from each other. So just kind of call your attention to a couple pieces of this diagram here. Right here is going to be your fault. That's where things break down. This plate is moving this way. This plate is moving that way. Over time, as these plates spread further and further apart, you're going to start to get a valley that forms, and then given enough time, those things will spread far enough apart that water could flow into them and form a large body of water, or maybe even an ocean. So just note a divergent plate boundary, two tectonic plates are moving away from one another. Your last boundary, which I'm not even going to draw on because it's got big old fat arrows on it, is called a transform plate boundary. In a transform plate boundary, the two plates just move past one another. Nobody goes under, nobody goes over. They just kind of slide to and fro. Now, let's get into why the plates actually move. This idea of convection is a big idea that you're going to see multiple times throughout the course of this class, so I want you to try to do your very best to understand it. Convection is based on the principle that as a material warms, it becomes less dense. Now, by less dense, here's what I mean. Our cool material might have the atoms all packed together very tightly. They're not moving very fast, so they just kind of snuggle up together. As you heat this thing up, all of our little atoms, they start to move around quicker and quicker and quicker, and as they move around, they spread out. They need more room, so they're not nearly as close to each other. They expand away from each other. This material that has just heated up is now less dense because its atoms are not as tightly packed. When materials are near each other, the least dense material is always on top, the more dense material is always on the bottom. So this means that as you heat a material up and it becomes less dense, it will rise above any materials that are more dense. So a good example of this is water. If you have, let's say, here's a whole body of water, we are going to put a flame underneath our water. As this water on the bottom heats up, it's going to become less dense and it's going to rise up towards the top of our pot. So that is the first part of connection that you need to be aware of. When things heat up, they become less dense. Less dense materials rise above more dense materials. On the opposite end of this, as a material cools, it becomes more dense. So let's say we've got our hot material where the atoms and molecules are all spread way out from each other. As this material cools down, all of those atoms slow down and they start to pack together. So we are becoming more dense. We are putting more atoms into a single space. So just like when something became warm and rose, as something becomes cool, it becomes more dense and it sinks. So if you've got materials that are fluid, like water or air or something like that, you're going to have anything that's warmer becoming less dense and rising up to the top, and anything that's cooler becoming more dense and sinking to the bottom. Now this process of rising and falling is called a convection cell. I've given you a little diagram here of the Earth if you were to just chop it straight in half. A couple things that I want to point out on our diagram here. Right here, this is the crust of the Earth. That is where we live. Underneath the crust of the Earth is the mantle. Now the mantle is made mostly of magma, which is fairly liquid and moves around a good bit. And then underneath the mantle you have got the core. The core of the Earth is super hot and it heats up the mantle. Because the mantle is being heated up, here's what you got going on. As the mantle material gets warm, it gets less dense and it rises up, and then as it cools off, it becomes more dense and sinks back down. So you get this cycle going on of our magma heating up and rising, then it travels along for a little while and gets cool and it sinks back down again. So that is called a convection cell. And know that convection cells don't just apply to the Earth, they apply to any material where you've got this pattern of things becoming warm, less dense, and rising, then cooling, becoming more dense, and sinking. Now, how does all this apply to plate tectonics? Let me show you. Our plates, like we said, ride on top of the mantle of the Earth. Now, you can think of this mantle as being like a conveyor belt in a factory. So I'm going to draw you a really quick little terrible diagram of a conveyor belt. Here's our conveyor belt. Man, that's bad. It's moving in this direction. Any box that you put onto this conveyor belt, because the conveyor belt is moving that way, the box will also move this direction. So you can think of our mantle right here as being like a conveyor belt. As it heats up and rises, it travels this way for a little while until it gets cool and sinks back down. As that magma is traveling in this direction, the plate that is on top of it, the Earth's crust that is above it, gets carried along for the ride. Same thing on this one right here. You've got your magma heating up and rising, then traveling this way and eventually falling down and cooling. The crust that is sitting on top of it will travel in this direction. I just realized that this guy looks like a little tank. Let's give him a cannon. Anyway, so out of this slide, I want you to realize that one of the forces that moves our tectonic plates, at this point right here we've got a divergent boundary, the plates are moving apart. The thing that's moving the plates apart is this magma convection cell, kind of making a swirling motion. As it swirls, it takes the plates along with it. Final thing for the day, two terms, ridge push and slab pull. Now, that convection cell is responsible for a lot of the movement that happens with our tectonic plates, but there's two other forces at work. Right here, where we have got our magma rising up, it pushes up the surface of the Earth into a ridge, so it's higher than the rest of the plate around it. Gravity says that anything that is higher wants to travel down. So because our ridge is higher than the rest of the plate, this ridge wants to move in this direction because gravity is pulling it that way. Now, because gravity is pulling it this way, it pushes. As it pushes the whole plate in that direction. Since the ridge is pushing, it's called ridge push. So now I hope you realize we got two forces going on. You've got your convection cell moving like a conveyor belt, and you've got ridge push pushing things in that direction. Last term for the day, slab pull. All plates have got two zones on them. They've got somewhere where they are moving away, and they've got somewhere where they're moving together. So let's say that we've got our plate right here. There's our ridge. We've got magma. Let's change our pen color. We've got magma rising up right here. We just said that ridge push makes the plate want to go this way. We've got another tectonic plate right here. So this plate is being subducted. It's moving under. As this plate moves down, as you can see right here, gravity pulls in this direction, because remember, gravity wants everything to move down. So you've got ridge push going on, but you also have slab pull pulling the plate in this direction. So working on our plate to cause it to move, you got three forces. You've got ridge push, pushing it this way. You've got your convection cell moving along like a conveyor belt, and you have got your slab pull pulling it down into the subduction zone. This is that area right there. Note that every plate on the surface of the Earth has each of these places. It has a place where it is divergent, it's moving away from another place, and it also has a place where it is convergent, where it's running into another plate. So I hope you were able to track with all of that. If you're confused with anything, toss your hand up, I'll come around and I'll help you out, and maybe we'll do this again sometime. So thanks for joining us, and I'll talk to you soon.